So I was just trying to break it up. And the reason I broke it up is because now 63 and 27 aren't perfect squares, so we have a little bit more work to do. So I always say numbers first. We're going to take 63 and divide it by either 2, 3, 5, or 7, and I'm going to divide by 3. 63 divided by 3 is 21. We can divide that by 3 again and we get 7. Well, 7's a prime number. Okay, so I ask, what are the pairs? Well, this is a pair right here. Okay, so just talking numerically, I would have 3 on the outside and a radical with 7 left on the inside. So the number's taken care of. Then I have to say, how many pairs can we make of 2? Well, 2 divided by 2 is 1. So you make 1 pair and there's nothing left over. So this would be your answer. Okay. Number 6, we're going to do the same thing. 27 is not a perfect square, so we need to figure out what to do with it. So we're going to divide by 3, and that gets you 9. You can divide by 3 again, and that gets you 3, and that's a prime number, so we're done. Okay. Ironically enough, we're dealing with 3's again. So 3 is a pair, but this 3 is left over. So we're going to write 3 on the inside, and the square root of 3, that 3 stays on the outside, inside of the radical. And then we say, how many pairs can we make out of n? Remember, this is n times n times n, so there's 1 pair. Or you can divide by 2, and that would be 1, remainder 1. So we'd have 1 set of pair and 1 left over. So n goes on the inside, or the outside, and the 1 gets left over in the inside. So it'd be 3n times the square root of 3n. Okay. Next problem. We're going to make it a little bit more difficult because we can. So we have 128. We all know that's even, so we're going to divide by 2. And that gets us 64. Now, some of you might notice that that's a perfect square, and you can stop and say that's 8, but we're just going to keep on going just to prove it. So divide by 2, and you get 32. Divide that by 2, and you get 16. Divide by 2, and you get 8. Divide by 2, and you get 4. Divide by 2, and you get 2, and that's prime. So there's a whole lot of 2's. So let's start here. That's 1. That's second pair. That's another pair, but this can't pair up with anything. Okay, so on the outside we'd have 2 times 2 times 2 because there's 1, 2, 3 pairs. And then on the inside, we know that there's 1 left over, so that stays there. So the numbers are done. Now you have to go for the variables and say, okay, how many pairs can you make out of 3? We can make 1 with 1 left over. So it'd be x here and x here because that's 1 pair and that's 1x left over. Then we take that divided by 2, the 5 divided by 2, and we know that to make 2 pairs with 1 left over because 2 times 2 is 4, and that 1 will give you 5. So with the y, you're actually going to have it squared because it makes 2 pairs, and then you're left over with 1. And then last but not least is the z, and luckily that's even, so that's going to come out nice and easy. So it's z to the 3rd power and nothing's left. And then you just have to simplify these two. So 2 times 2 times 2 is 8. We'd have x, y squared, z cubed, and 2xy. And that's the answer. Okay. Now this negative means nothing, so don't let it freak you out. 144 is a perfect square, and the square root of 144 is 12. So I'm just going to write equals 12, and I want to keep that there. And then we have to do the variables. 16 divided by 2 is 8. There's no remainder, so it'll be x to the 8th power. And then I'll say, how many pairs can you make out of 10? Well, you can make 5, because 10 divided by 2 is 5, and I'm running out of room, and z is odd, so it's going to have a remainder left here. So you can make 3 pairs, because that gets you 6, and that would give you a remainder of 1. So you have z cubed and z on the inside. Alright, so that's square roots, but I also have to teach you a little bit about cube roots. So go ahead and listen to the next video to get that, and that will be the remainder of the notes.